Alright, so this next section talks about the inverses. So let's just remember really quick that when you have an inverse, you're basically flipping x and y around for the graph. Okay, so if you have a function y equals 3x plus 2, the way that you find the inverse is you flip x and y, so this becomes x equals 3y plus 2, and then solve for y again. Okay, so that's just one thing to remember. The other thing is the horizontal line test. So you determine that a function is a function. So y equals x squared, for example, is a function because it passes the horizontal line test. But we know that the inverse of this, so x equals y squared, and the inverse would then be, you take the square root of both sides, so you have y equals the plus or minus square root of x. The inverse is not a function because it fails, sorry, this was the vertical line test, and it fails the horizontal line test. Okay, so it's not a function because it fails the horizontal. So keeping that in mind, the same thing happens with the inverses of sine, cosine, tangent, cosecant, secant, and cotangent. And here's why. So looking at the actual function, I tried to find just a nice picture. If you look at the function of cosine, for example, it keeps on going forever and ever and ever. Now it passes the vertical line test. So we know that cosine is a function. But we also know that the inverse of cosine is not a function because if I draw a line through this, it fails the horizontal line test. So what this means is in order to have the inverse of cosine of x be a function, I'm going to need to restrict it. I'm going to need to restrict it to the point where basically where does it pass. So I see here that it fails here, so that means I'm going to cut this part off completely. And then after this, we know that the graph goes back down, so it starts to fail. So what I see here is that where does the cosine function pass the function test horizontally? Only from 0 to 2 pi. So for this to be a function, I have to restrict its range. And the reason I say the range is because remember, x and y is going to get flipped, so we'll talk about that in a little bit. So we're going to restrict it, and the only way that this is a function is if y is going to be between 0 and 2 pi. Same thing happens for sine. Okay, so you notice that if it fails, obviously, the horizontal line test, that means the inverse of this is not a function. So the only way that it is going to be a function is if I restrict the domain. And I can restrict the domain basically from pi over 2 to negative pi over 2. And I mean, I could take it over this way to 3 pi over 2, but you'll see why we chose that specific domain in a little bit. And then the same thing here. So the only way to restrict it is to go from negative pi over 2 to pi over 2. But here what's important is to understand that these 2 points are not included. Alright? So when we restrict them, here are our functions. Okay? So basically imagine this. This was the original function if this was the x and this was the y. But now arcsine, or aka the inverse of sine, is now restricted, the range is restricted between negative pi over 2 and pi over 2. Cosine, the range is restricted between 0 and pi over 2. And here it's between negative pi over 2 and pi over 2, but of course the difference between these two is in this one pi over 2 is included, and in this one it's not. It's an asymptote. Alright, so now, knowing that, let's actually write down our definitions. So inverse sine function is y equals inverse sine of x, or y equals arc sine of x. It means the same thing as saying x equals sine of y. So basically, whenever they say arc sine of x, you're asking yourself, sine of y is equal to x. Okay? And here, it's restricted from negative pi over 2 to pi over 2. So what that means is that my answers for anything that deals with arc sine is only going to be in the quadrant 1 and quadrant 4. Okay? Inverse cosine is written like this. And it means x equals cosine of y. Now here it's restricted. Range is from 0 to pi, like we talked about. I'm sorry, the restricted domain. I don't know why I just said range. It's from 0 to pi. And what that means is that our answer is going to lie from 0 to pi. It's in quadrant 1 and quadrant 2. And now our tangent, our inverse tangent, is y equals tan of negative 1, or arctan, y equals arctan of x. It means x equals tan of y, and it is restricted domain between negative pi over 2 and pi over 2. And you notice that I left them in parentheses because they are not included. So it's hard to show this, right here, but it is within this quadrant, but this line I should have made it a dashed line because those points are not included. Okay? Alright, I'm not going to redraw these, but here is the quick image of the 3. Alright, you notice that the radians are basically flipped around, and then your x becomes your y becomes your x. Okay? So pause the video on this and you can draw those in. Alright, so why is this important to us? So here's why this is important to us. How do we find y in each of the following? So basically the question here is, now another way of writing this, of course, is arc sine of 1/2 equals y. So your x, in this case, is your 1/2. So if I rewrite this, I'm basically saying sine of y is equal to 1/2, right? We flip x and y. So here the question is, sine of what is equal to 1/2? And we know that sine on our unit circle, sine of pi over 6 is equal to 1/2. Now remember that your restricted domain for sine is going to be in what quadrant? It's going to be in these two quadrants. And for this to be a positive 1/2, I know it has to be in quadrant 1 because sine over here is negative. So that's why it is going to be pi over 6 and not 11 pi over 6 because it's not negative 1/2. So my final answer is arc sine or inverse sine of 1/2 is equal to pi over 6. Easy. Easy peasy. Alright, so here the question is, again, this is your x value. So if you switch them around, you're basically saying sine of y, sine of what equals -2. So think of your unit circle. Do we have a -2 anywhere on the unit circle? Or basically I should ask you, is -2 within the domain? Within this domain? And no, it's not, because nothing, sine of nothing is going to give us -2 within this domain, unless we keep on going on forever and ever. Alright, so this answer, it does not exist because -2 is not in the domain of negative pi over 2 over pi over 2, in the domain of the sine function. Now, could it have been in the domain of cosine from 0 to pi? Well, it depends on the problem, so I'm not going to say for sure right now, because cosine is going to be x, and so it's a little bit different. But yeah, I mean, it could have, because the domain for cosine is from 0 to pi, and no, it's negative. It's negative still, so we don't have, that's not in the cosine domain as well. Alright, sorry for that little confusion. Alright, so number 3 is asking cosine of what is equal to 1? And that's easy. Where is cosine 1? And remember, for cosine, our domain that we care about is from 0 to pi. Alright? And if we remember over here, it's 1, 0, and over here, it's -1, 0. So where is cosine 1? Cosine 1 is right here, and that happens to be at 0 radians. So that means that y is 0. So cosine of cosine inverse of 1 is 0. Alright, so next up, cosine of where is -√2 over 2. So remember, we have to stick to our restricted domain for cosine, which is in this quadrant right here. And you remember that the fourths are going to be your square roots of 2 over 2, square root of 2 over 2. But here, cosine is positive. So obviously it's going to be in this area right here, which is 3 pi over 4. I know that's very small. So cosine of 3 pi over 4 is equal to negative square root of 2 over 2. So the way we write our final answer is inverse cosine of negative square root of 2 over 2 is equal to 3 pi over 4. Okay? All right, 2 more. All right, so 2 more. Next one. Tan of what is equal to 1? Now, if you remember that tangent, where is the restricted domain? It's within these 2 quadrants. Okay? And remember that tangent is sine over cosine. And the only way that you can end up with a 1 for sine over cosine is at the quarter marks. So it's either going to be at pi over 4 or 7 pi over 4. Sorry, this is pi over 4. And 7 pi over 4. I don't know why this is blurry today, but we'll figure it out later. Alright, but it has to be positive. And we know that here sine is going to be negative, so that would have given us negative 1. So it can't be this. So it's obviously pi over 4. So the way we write our final answer is inverse tan of 1 is pi over 4. Alright, let's do this one together in class tomorrow because I don't want this video to go on forever. So we'll do that one in class together, or you can try it on your own, of course. Alright, the other 3 functions, you have to understand the domains and the quadrants that they're in. We're not going to really do too many problems with them. But the domain for cotangent is actually going to be all reals. The interval, the restriction for cotangent is going to be for inverse cotangent, is going to be between 0 and pi, and they're both not included because you remember that cotangent, that these 3 functions have, well, this function has asymptotes. Okay? So this function does have asymptotes, and so do the other 2. So the quadrants for 0 and pi are going to be Q1 and Q2. The domain for secants, for inverse secants, is negative infinity to negative 1 included, union, and then from 1 to infinity. But the restriction interval for the secant is going to be 0 to pi as well. The 0 to pi is included, except y cannot be pi over 2 because there's a asymptote at that point. And the 2 quadrants is Q1 and Q2, except for y can't be pi over 2. And then the same goes for cosecant. But here, the interval is going to be from negative pi over 2 to pi over 2, but y cannot be 0 because that's our asymptote. And then Q1 and and Q4 are our quadrants. Alright, this next section, I'm going to start it off with you. We're going to do an easy one here. You can try to do the others, but we're going to do them together in class. Alright, so what you have to do, evaluate without using a calculator. So just like in all equations, you kind of start on the inside. And we're going to say, we're going to let theta equal this, tan inverse of 1, 3 over 2. So just like we were doing before, so I'm going to let this whole thing right here equal theta. So later on, once I figure this part out, and then I plug it back in, then the last thing I need to solve for is just sine of whatever my theta ends up being, right? Outside sine, and this guy is going to be my theta. But to solve this, it takes a little bit of work. All right, we're going to have to use triangles here. So first off, we're going to use the inverse notation that we just learned. So we're going to rewrite this as something that we know, which is the actual tangent function. So if we flip around our x and our y, this becomes tangent of theta is equal to 3 over 2. So when we're given this information, we can basically figure out the three parts of the triangle. So if I draw my triangle right here, my right triangle, and let's let this guy be theta, whatever theta is, I mean, who cares at this point? And we know that tangent of theta is 3 over 2. If you remember SOHCAHTOA, tangent, this is TOA, so opposite over adjacent. So if this is theta, opposite of theta is 3, adjacent to theta is 2, so what is my hypotenuse? And of course, how do you figure this out? Use the Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus 2 squared equals c squared. 9 plus 4 is c squared. 13 is c squared. So square root of 13 is c. So I get square root of 13 for my hypotenuse. And now that I figured out the three parts of my triangle, then guess what sine of theta is? Sine is the SO out of SOHCAHTOA. So what is opposite of theta? 3 over the hypotenuse, which is square root of 13. But of course we can't have a radical in the denominator, so we multiply the top and the bottom by square root of 13, and you end up with 3 square root of 13 over 13. Okay? So why don't you try doing this one? Let this guy be theta. So theta is equal to cosine, so inverse cosine of -1, and this is -5 over 13. Rewrite that. So cosine of theta is equal to -5 over 13. And it doesn't matter which one you make negative and positive, because in the end they're both going to be included in the equation. So now when we make our triangle, this is theta, and it's cosine. So cosine is the ca. So this guy right here is adjacent, and this is my hypotenuse. So adjacent is, actually, there is a reason for this. And the reason is we have to remember that I drew my triangle wrong. Okay, because remember, you're drawing your triangle on the unit circle. By drawing it this way, I'm making the x positive. The hypotenuse will never be negative. But because this is negative, I actually have to draw my triangle this way, so not like that. So if this is theta, and then this is negative 5, and then this is 13, we figure out our opposite, and then we can find our tangent of theta. So it would be whatever this is over negative 5. Alright, so I'll let you guys finish that up, and then we'll finish the rest of this up in class tomorrow or the day after. We'll figure it out. Alright, good night.